problem just to, just to get the basics down. You know what I mean? Yeah, I like the problem on the board. That's the first thing. And specifically, the whole thing here. And I'm sorry, I'm terrible with names. Michelle? No? Okay, good. All right. So the whole idea here is to really, when it comes to general chemistry, it's all about the you recognizing what you need to know out of the problem. So let me just try that here. So suppose you had, and I'm going to put, when I write this problem, I'm going to put the things that are important in color, because that's the only thing that's important. The rest of it is just some bullshit. Just keep it real with you. Yeah. So okay, this is, okay, suppose you had a 3.15 liter sample of neon gas at, this is important, 21 degrees Celsius is important, 21 degrees Celsius, and a pressure of 0.951 ATM. Okay? Okay? It says, what would be the volume of this gas if the pressure were increased?
Is all of that, I think the fact that it's like that huge paragraph, all that, is all that was really necessary?
Well, some of it's necessary. And the thing is, it's really just a filler. You know, of course, give me 1 second. When I go, let's see, increase to up 1.292 ATM. Wow. The temp remain constant. This is important. I like it like this. Okay, so let's talk about this. Let's read this. So it says, suppose you had a 3.15 liter sample of neon gas. Let's start anytime you read this problem, you need to be able to visualize it, and I'll tell you what I mean. So let's say we have ourselves a beaker right here. And inside this magic beaker, I guess you could say, inside this magic beaker, that purple stuff right there, that's what you call neon gas. It's neon, and of course, it's a gas. Okay, so this is what we have. And specifically, and to be honest with you, it's not going to be a liquid, of course. It's going to be like this. I'm sorry. If it's a gas, it's going to look like this. Like that. Okay, now, it says suppose, and specifically, notice what I'm doing. I'm taking all the colors from over there, and I'm painting the picture with the colors.
Okay.
So you can see it says, suppose you had the blue. Now the blue comes in. That right there, all that blue stuff that's right there, it's 3.15 liters of this purple stuff, whatever it is. And it says of neon gas at 21 degrees Celsius. Okay, something else important, that's green. So that right there, whatever this purple stuff is, it's this hot. This is how hot it is, 21 degrees Celsius. Okay, and it says, and the pressure, something else unique about it, a pressure. And the pressure is going to be yellow. So again, there's something important about this purple stuff. It's at 0.951 ATM. It has a pressure associated with it. It says, what would be the volume of the, now notice, they're saying what would be. And this is important. I should underline this. This is important. That right here. Okay, now, I think what would be. Because anytime they're saying what would be, they're talking in future tense. And if you're talking in future tense, they're saying what would the volume of something be. This is known as V2. Because the thing is, anytime you relate to a gas, this is the thing you got to realize. You got to realize this. Anytime you got yourself a gas, right, you got to realize this. There's certain things associated with any type of gas. Pressure, volume, temperature, and what else? Something else you'll see. You'll see moles. So these are the only things you're going to see related to a gas. And since these are the only things you're going to see, this is what you need to be looking for when you read the problem. Okay, right, and when you read the problem, it says what would be. Now, if they say what would be the volume, they're referring to this. They're referring to the green one, volume. and they're saying what would, and they're saying what would, they mean future tense. And it's only, when you work with these gas laws, you're only focusing on two things. You're focusing on what's with us right now in the present, and what's in the future. And anytime you're referring to what's in the present, you say one, because that's where we're at right now. And two is where we're going to be, the future tense. So when they're saying what would be the volume, they're referring to V2 when they say this. Okay, they're saying what would be the volume of the gas if the pressure were increased to. Again, they're talking in future tense. In the future, something that's going to happen to us. And since they're saying that this right here, and they're saying that this is a pressure, and we can see by the unit that it's a pressure, so we know that that right there is going to be P2. Because again, they're talking in future tense, and they're talking about something being increased. That's something that happens in the future. And they're saying this while the temperature remained constant. Now, let me tell you something. Anytime they're saying that something is constant, when they're talking about these gas laws, you don't put it in the equation. As a matter of fact, you don't even write it. Because if something does not change, you don't worry about it. Because notice all these equations are based off things that happen, that are compared to now and something that's happening in the future. We don't worry about things that, for instance, if I was 10 pounds down and 10 minutes later I was still 10 pounds, who cares? But if I was 10 pounds down and then I was 5 pounds, something changed. We're worried about the change here. Now, if you look at this, you can see this, right? Now, the thing is, we started to put these pieces together. So far, we have this. So far, we have a couple things. That pressure, we're going to put right here. Now, so far, we got P2. We said that P2 was equal to 1.292 ATM. You agree?
Yes.
Okay, we got that so far. We know that we don't know what this is yet, right?
Yeah.
Now, automatically, when I see this right here, well, right off before I do anything, I write the general gas law. And the general gas law is P1, V1, T1 is equal to P2, V2, T2. And this is just an equation. This is something you got to memorize. And what this is right here is this right here is reason I write it like that is this thing is this right here. This is Boyle's law. This equation right here is Boyle's law. Boyle's law plus Charles' law.
Yeah, okay, cool.
Yeah, it's both of them combined. Because of course you know you got two separate equations. P1 and V1 is equal to P2 V2. Then you got this thing like V. It's a bunch of different equations. And we're just gonna use this one here. And the thing is this: we're gonna use this one, but notice how temperature remains constant, right? Now think about this. Let's say over here, if the temperature, notice they set the temperature to 21 degrees Celsius, right? Now if you've got 21 degrees Celsius over here, and 21 degrees Celsius over here, it's the same on both sides. And since it's the same on both sides, that means it doesn't even matter. So then you come up with just good old-fashioned Boyle's law. P1 V1 is equal to P2 V2.
Okay.
And so if you know the general gas equation, you can get any of them from that one if you just know one of them.
Okay.
So
If I just know the P1, V1?
well, if you know this one right here, P1 V1 divided by T1, the whole thing is this, N1 is in there too, is equal to P2 V2 divided by T2 N2. And specifically, if you use that equation, you just take out what pretty much when you tab this, when you're doing the problem, you're going to take out whatever remains constant. Because if it remains constant, it's just 1 on both sides. And if it's just 1 on both sides, it doesn't even mean anything really. So you take this and you just use whatever changes. And specifically, we use P1 V1 because it changed. And specifically, we got V2, which means we need to define at least 2 more other variables. We need to define V1. We need to define V1. Okay? Okay. So now if we look up there, we can see it says suppose you had. Now if you have something, that's in the present tense. So that 3.15 liters, that liters is a volume, right?
Yeah.
And that 3.15 liters, that volume is going to be 1, the V1. I mean the V1 because it's in the present.
Okay.
Okay, we're going to use blue. So V1, we know what it is. It's going to be 3.15 liters. Now we just need to figure out what this P1 is. Oh, let's see. So, okay, it says, suppose you have a 3.15 liter sample of neon gas at 21 degrees Celsius and a pressure of look at that. We just found what P1 was because they said you have a neon gas. All that blue, that green, and that yellow are what's in the present, in the right now. Okay, so the P1 is going to be yellow, and we're going to say that it's going to be 0.951 ATM. Okay, now, so we got everything we need. All we need to do now, because the thing is, we got 3 variables, and then, you know what algebra, of course you know what algebra says. if we have 4 variables, we need at least 3 to solve for 1.
Yeah.
Okay, we know that. And so what we're gonna do now is take that equation and algebraically rearrange it and solve for V2.
Okay.
Okay, so if we got that equation, if we got P1, V1 is equal to P2, V2. We're trying to solve for V2. If we're trying to solve V2, we need to divide both sides by P2. This gives us V2 is equal to P1, V1 divided by P2. That's our equation right there.
How do you know if so I don't know what they're asking, if it like by the word pressure, I don't know what they're asking.
Well, right, to know what they're acting, to know which one is unknown.
Yeah, to know the equation.
So to know which one is unknown, in the problem, it said right here, what would the volume be of this gas? I'll say, read it one more time. What would be the volume of this gas? They're saying, what would it be? Right off. If they ask you, what would the volume be? And if they ask you, what would it be? Well, they're saying, what would the volume? You know it's going to be V because they said volume. And when they say, what would it be, they're referring to the future tense. So this is V2.
Okay.
So this is how we knew.
Okay.
So we're going to rearrange it algebraically, and we get this equation. So
Okay.
now it's easy, because all we do is just plug the colored numbers in. Because now P1 is going to be the yellow number.
Yeah.
The yellow number goes here, so it's going to be 0.951 times the V1, which is the blue number, 3.15, and then we divide it by the orange number, which is P2, the orange number, which is 1.292. So now we just break out our calculators, and then we check our final answer. Let's see, and this problem is 5.39. We're gonna go back here. 5. Okay, so, all right, so let's do some math. So let's see what volume this neon, this purple stuff is going to turn into. What volume is it going to turn into? Okay, so right off, let's do 0.951, and that's, we can just multiply that times 3.15. And then enter, of course, and then divide that number by 1.292. Okay, so the answer should be 2. V2 should be equal to 2 point, what liters?
319.
Liters. All right, so let's check that answer in the back of the book, and we'll pick back up tomorrow. So it's right here on this page, and it should be 5.39.
Okay, so is it 5 point?
39?
It said 2.32.
Okay, and,
Oh, okay. Well,
and you see this, right?
yeah.
Right, I mean,
I
you know.
went too many decimals.
Oh, no. Well, let me say this, because a lot of people don't like this about general chemistry. Okay, let me ask you something. 2.32, and this number right here, 2.319. What's the difference between those two numbers? Not a damn thing. Those are the same damn numbers. So that's the right answer.
Okay.
So don't even worry about those small round areas. What you're gonna do on your test is pick the closest number.
Okay.
That's what it's all about. So for instance, if you're in a situation where you have A, B, C, D for that answer, and then he says, okay, one of them he says he got like 1.73, another one is 2.99, another one is 2.38, no, 3.18, and another one is like 5.7. A, B, C, or D. C. And even though it's not even the exact answer, it's the closest answer out of all the answers.
Okay.
So this is the type of thinking you should have.
Cool.
Okay, good.
Thank you.
I'm happy we got one done.
Thank you.
I'm happy. Michelle, right?
Yeah.
Okay. I hope I